Okay, so this week I'm going to talk about the x and y intercepts more in detail. Y-intercept you should already be familiar with when it comes to linear functions. X-intercept will be a new definition that I'm going to go over. Both of them, I will cover them in detail. Okay, and next class I'll talk about domain and range once again because I think that's a fairly confusing concept. And then that will be it for chapter 6. And on Thursday you will have your test. Um, and the test will be on Thursday because I believe Friday is a PD day. But I guess I'll have to check my calendar to be sure about that. But I'm pretty confident it's a PD day. Anyway, so how do you um, find the x and y intercepts. Let's just wait for that for now. Um, that will be given to you in a moment. But for the starter question, I'm just going to ask you to graph this function. Okay, so this one might give you a really hard time because remember, a linear equation, right? To graph a linear equation, it needs to look like this. Y is equals to mx plus b. Okay, but what you have up here is not looking like that, okay? If it's not looking like that, then you'll have to use a little bit of algebra to make it look like that, okay? So once you have this form, it should be fairly straightforward, but you don't have this form to begin with, right? So what should you do? Okay, so you need to, as you can see in this equation, you need to isolate for y. So that means you have to get rid of everything that's not y. So there's many ways of doing this, right? So if you have a minus 6, to get rid of this minus 6, you have to do plus 6, and then you do the same thing on the other side, so plus 6, and then the 18, right, becomes minus 18, and then you do minus 18, right? So this will disappear, and then you're going to have 2y is equals to plus 6x is just 6x minus 18. But even now, I'm not um, I'm not quite there yet because right, let's just focus on this equation, right? What's the coefficient of y over here? If it's not given, it's 1, okay? But currently my coefficient is 2, so I need to get rid of this 2, which means that I have to divide this by 2. Now, when you divide by 2, you have to divide the whole thing by 2, okay? Because it's there's a minus sign, so the 2 and the 2 will cancel, and your equation will become y is equal to, you have to divide the 6 by 2, so this becomes 3x, and then you also have to divide the 18 by 2 to get minus 9. Okay, so now it should be somewhat obvious on how to sketch this. Okay, and sometimes they will do this. Okay, sometimes intentionally they will give you maybe let me not erase this, but sometimes intentionally they will give you a question like this, which will kind of like throw you off. But if you rearrange it, right, and solve for y, kind of like how I did, then it shouldn't be too bad. Okay, so using this, let's identify. So what is my slope? My slope is equals to my m value, which is 3 in this case, right? It's just the coefficient of your x term, and it's positive, so my function will be rising, right? And my b value, which is my y-intercept, right, is minus 9. Okay, so this is the point, right? If you want to write this as a point, right? So this is the point where x is 0 and y is minus 9. Okay, so how would you graph this? A table of value would be nice, right? So x, y, you know one of the points, right? You know that at 0, you're at negative 9. Um, and um, and then you can pick another point, right? So again, because your denominator is 1, you could increase your x values by 1. There's no problem. And you know what? Let's actually do that. So at 1, right? Um, so if you plug in 1 into your function over here, right? So if you replace x by 1, so it's your y value will just be 3 times 1 minus 9, which will be minus 6. And when you're at 2, then you're going to be replacing this x value by 2. So 3 times 2 is 6, and minus 9 will give me minus 3. Okay, and it kind of makes sense because remember, this is your slope, right? This is your slope. So whenever you increase your x value by 1, right, because your slope is positive, your y value has to increase by 3, right? So remember, slope by definition is the change in y divided by the change in x. So this is your change in y, and if you divide by the change in x, you should get your slope, which is 3. Okay, and which is what we do. Okay, so this is where it's coming from. You can You can kind of like find those values by you know, using this technique. But the best way, in my opinion, is to just plug in the values in your function, right? So let me just do one of them. So right, so when x is equals to 1, you can find your y value by replacing x by 1. And then when you work this out, you're going to get minus 6. Okay, so this is how I got those values from. Okay, and maybe one more just for those of you who are somewhat confused. When x is equals to 2, then you just replace your x value in your function by 2. So 3 times 2 minus 9. And this is where the minus 3 is coming from. Okay, so this is how you find your values. Now, to make some room, I'm going to erase all this, because this was just to show you where it's coming from. And now once you look at the table, right, you can kind of like have an idea of how to scale your x's, okay? Your x values are increasing by 1. So I would scale my x axes by 1. Okay, so if this is 0, then this is 1, this is 2, and this is minus 1, this is minus 2 if you want. Now, y value, you have a choice. But it seems like if you scale this by 3, then you're going to get 9, 6, and 3. So I'm going to scale this by 3, and then 6. So you have minus 3, and you have minus 6. And let's just go a little bit underneath over here, minus 9. So this is where my function is starting, right? The point 0, 9. My next point is at 1, I'm at minus 6. And then at 2, I'm at minus 3, but you don't really need the point here. All you have to do is just connect two dots, and this is basically what the function looks like. Okay, so something like that, okay? Um, so again, there will be a sketching question on your test. So I know that on the quiz, I had already given you a sketch, and I was asking you, I think I gave you an equation, and then I gave you a sketch, and then you have to find which sketch represents the equation. But on the test, you're going to have to draw this, kind of like how I did. Okay, so if you don't understand this, please come visit me during my office hours so that I can help you. Okay, so so let's move on. Okay, so now let's talk about okay, so a linear function. Okay, recall um, the any linear function that any linear function can be represented. This should have been a that. Okay, so that any linear function can be represented by the following equation, as you saw in the starter question. Now, here are some definitions. Okay, so y-intercept is the y value of your function when x is equal to 0. Okay, so y-intercept is basically, right, when your function, right, this is my function, so let me draw the function in a different color. So when my function intercepts the y-axis. Okay, so remember, this is x and this is y, and this point, right, the function intercepts the y-axis at the point 0 when x is 0, and your y value for a linear function will always be b. So for a linear function, it isn't difficult. Like, it's only by inspection you can see that this will be my y-intercept. Okay, so because remember, right, in a linear function, m is your slope, right? M is your slope and B is your y-intercept. So you don't have to do any calculation to figure out the y-intercept. You only have to look at the uh, intercept by inspection, right? And you can only use this if you've solved for your y. Remember, your coefficient of y should always be 1. Okay, if it's not 1, then you need to get rid of whatever that coefficient is, and that will give you your y-intercept. Okay, so by inspection, you know what the y-intercept is, but by definition, how do you find this? Okay, so this is how you find the y-intercept. So y-intercept, okay, so is given by y is equal to, just replace, right? So in this equation, I'm going to replace x by 0. So 2 times 0 is 0. 0 minus 6 will give me minus 6, okay? Now, this is really important. Y-intercept is the point when x is equal to 0, okay? Now, eventually, you're gonna work with different functions that are not linear. So in this case, this is a quadratic function that you will work with in grade 11. But here, if I'm asking you to find the y-intercept of this function, some of you might naively assume that it's just -1, but that's not true. Okay, so how do you find the y-intercept? Sometimes it's difficult to find the y-intercept just by inspection, but if you go by definition, so y-intercept is the point where I have to replace my x value by 0. Okay, so I'm going to copy the function 3 and then brackets. I'm going to replace this x value over here by 0. It's going to become 0 minus 2 squared minus 1. And then just simplify this, right? So 0 minus 2 is just minus 2. So this just becomes 3 minus 2 squared minus 1. Okay, and if you're not too sure how to simplify this, just when you're simplifying, you have to do BEDMAS, okay, in forward direction when you're simplifying. Okay, when you're solving, then it's in reverse direction, but here you're simplifying. You just need to clean this up, right? So start with your brackets, which is what I did, okay, then deal with your exponent, and then multiplication, and then addition and subtraction, okay, so which is what we're going to do. So, and again, if you're confused, you can always use your calculator. So this just becomes 3. Now, minus 2 squared is minus 2 times minus 2, which is 4. And then this just becomes 12 minus 1, which is 11. Okay, so your y-intercept is, so maybe, yeah, let me just write down the final answer. So your y-intercept is 11, okay? Because 4 times 3 is 12, and 12 minus 1 is 11. So it's not minus 1, as you can see. Okay, so how do you find the y-intercept again? Whatever your function is, it doesn't matter how complicated your function is. All you have to do is replace the x value by 0, and you will get your y-intercept, okay? So y-intercept, again, happens at the point, so it's the y value of your function when x is equals to 0, right? So if I were to write this as a coordinate, right, as a coordinate, this would be my x is 0, my y value is 11. Okay, so this is my y-intercept. Okay, and if I were to write this as a coordinate, then this would be the point 0 comma minus 6, right? So when my x value is 0, my y value has to be minus 6. Okay, that's how you find the y-intercept. Okay, so this is me writing it as a coordinate, okay, but your y-intercept is your y value. Your y-intercept is minus 6, but if I were to write it as a coordinate, then this is how I would do it, okay? Same thing over here. My y-intercept is actually y is equals to minus 11, but as a coordinate, this is what it will look like, okay? Now, the new definition that I'm going to talk about today is um, x-intercept, okay? So x-intercept, just like the y-intercept, is the x value of your function when your y value is equals to 0. Okay, so now here you're going to replace y value by 0 and solve for x. Okay, so what do I mean by x-intercept? So, right, graphically, x-intercept means the point where your function, let's say, crosses the x-axis. So this is the point that I'm interested in, right? So this is my x-intercept. Okay, so this is what I mean by um, um, x-intercept. Okay, and for my emergent students, okay, you guys have totally different words. Okay, y-intercept is like ordonnée à l'origine, and x-intercept is l'abscisse à l'origine. Okay, so it it's not the same as in English, so make sure you're looking at the French notes. Anyway, so this is the x-intercept, and this, right, this, I don't know what the x value is, so I'm just going to leave it as x, but I know what my y value is for this point, right? And you can kind of like come to a conclusion that my y value is 0. So, right, so this is what this definition means. It's the x value of your function when y is equals to 0. Okay, so how do you find the x-intercept? Let's do that. Okay, so let me just do this in green to distinguish the two. Okay, so x-intercept, right? You calculate x-intercept by replacing your y value by 0. So I'm going to replace this y, right, by 0. So 0 is equal to 2x minus 6. And then solve for x, okay? So here you're solving, right? So again, if you're not sure how algebra works, when you're solving, now here I'm not simplifying, I'm actually solving for an unknown. Then you have to do BEDMAS in reverse direction. Okay, so get rid of addition and subtraction first, followed by multiplication and division. Okay, so let's get rid of this plus 6, minus 6 by doing plus 6 on both sides. Okay, so then I get 6 is equals to 2x. And then finally, or you know what, let me just be consistent with my colors. So let's just stick with green. So 6 is equals to 2x, and now get rid of your um, multiplication. Do the opposite, divide by 2, divide by 2. So this tells you that, x is actually equals to 3. Okay, so this is my x-intercept. Okay, and one way to check is plug in this value, into your function and see if it actually gives you 0. So 2 times 3 minus 6, and that will give me 0. So that means I have done this correctly. Okay, so you can always check. When I plug this value into my function, do I actually get 0? Okay, so this is your x-intercept. But if I were to write this as a coordinate, then this would be the point 3, comma 0. Okay, so it's the x value that makes your y value equal to 0. Okay, so let's do one more example, right? So again, x-intercept, right? How do you find it? All you have to do is replace y by 0. So 0 is equals to minus 15x plus 15, and solve for x. Okay, so here I'm going to do the algebra a little quickly. Minus 15, minus 15. So this cancels out. And then I have minus 15 is equals to minus 5x. So now I have to divide by minus 5. And you divide by minus 5, so this cancels out, and then your x-intercept is equals to, in this case, it's also 3. Okay, so in both cases, it happens to be 3. This is just a coincidence, okay? And one way to check is to plug in this value in here. So negative 5 times 3 is negative 15. Negative 15 plus 15 will give you 0, okay? It should. And if it doesn't, that means you've done something wrong. So this is your x-intercept. Okay, this is your x-intercept. But if I were to write this as a coordinate, right, it's just the coordinate 3 comma 0 again. But this was just a fluke, okay? So maybe I should have chosen a better example. Sorry about that, but it's not always going to be the point 3, okay? It just happens to be 3 in this case. So now, why is the x-intercept so important? You will see that next week. Why is it so important? But for now, it's very useful when it comes to sketching graphs, okay? So what do I mean by that? So graph the following linear function using x and y intercepts. Okay, so before you start doing anything, make sure your function is written in the form. Here I'm going to change the color back to red. Okay, so before you start doing anything, make sure your function is given in this form, mx plus b. Okay, but this one is not. But all I need to do is just get rid of the 5, right? Again, there's many ways of doing it. You can move the 5 over, change the sign, right? So it will become plus 5. Or if that kind of bothers you, then just do plus 5 and plus 5 on both sides. So this cancels out. So your equation is y is equals to, you know what, just to save some space, I'm just going to put the equation up here. Okay, so y is equals to minus 2x plus 5. Okay, now how do you quickly sketch this function? Find the y-intercept. Okay, y-intercept is easy, right? Y-intercept, you can kind of like figure this out by inspection. It's just 5, right? But if you were to do this algebraically, then it's just y is equals to minus 2, replace x by 0. So I'm just gonna place this by 0 and then plus 5. So y-intercept is 5, and the coordinates of this point is, when my x value is 0, my y value has to be 5, okay? But this is your y-intercept, okay? Now for the x-intercept, a little, I guess, tricky. Okay, so you have to replace your y value by 0. So let's do that. Replace y by 0, and then you get minus 2x plus 5. And then you have to do a little bit of algebra, right? So minus 5, minus 5. So the 5s will cancel out. And that doesn't really leave me with a lot of room to sketch. But you know what? I'm actually going to add an additional page. It's fine. So this gives me minus 5 is equals to minus 2x, because this will cancel out, right? And then if you solve for x, then x will just equals to minus 5 over 2, minus 2. right? Because I'm going to divide by -2, I'm going to divide by -2, so this cancels out, which is equals to 2.5. Okay, so this is just equals to 2.5, and again, you can check, right? So plug in 2.5 into your function. 2.5 times -2 is -5. -5 plus 5 will give me 0, so it works out. Okay, so that's how you would check. Now, the coordinate of this point is when x is 2.5, my y value is 0. Okay, so for this function, I'm actually gonna do this on the side, but if you want, right now you have your coordinates, so you kind of have your table already, right? You know that when x is equals to 0, y is equals to 5, and when x is equals to 2.5, y is equals to 0. Okay, so now the question becomes, how would you here again, guys, I'm not gonna ask you to graph, I'm only asking you to I mean, you could graph, I guess, but yeah, I mean, it would be somewhat challenging to do that, because I've shown you how to graph in the starter question, right? The best way to graph would be to um, increase your x values by 1. Okay, so but you know what? So let's do that. Let's increase our x value by 1 because my denominator is 1, right? So my denominator over here um, is um, is 1, right? So it would make more sense to increase the x value by 1. So let's do that. 1. If I increase my x value by 1, then if I plug 1 in here, then 1 times -2 is -2. -2 plus 5 will give me 3, which kind of makes sense, right? If I increase my x value by 1, my y value should be decreasing by 2 because that's what the slope tells me, right? So this is one of the points that I guess you could kind of like add, and then you can go with the x-intercept that we already have over here, okay? So what do I mean by graphing using the x and y intercept? This is what I mean. Okay, so one way to quickly sketch, right? Sketching means you don't have to scale your x and y axis. Okay, so if I'm asking you to sketch, the best way to sketch is just start at the y-intercept, and then so this is the point 0, 5, right? And my x-intercept is over here, 2.5, 0, and then just connect these two lines, and sorry, not like that. So connect these two lines, and then you're done. Okay, so this is what the sketch of this graph would look like. This is what the sketch looks like. Okay, so now you have two very important points in your graph, and I will talk about why are these points so important a little later. But you see, nothing has been scaled. Okay, so if I were to ask you to graph this by scaling it, then you're probably gonna have to look at this table and do this a little nicely. Okay, so by looking at this, I think it's really a wise thing to increase your x values by 1. Okay, so I am gonna do that. Um, this is gonna be really hard to erase. Okay, I did that. Okay, so now let's increase the x value by 1 again because my denominator is 1 over here. So 1, 2, and then 3, right? And so this will be -1. And for the y values, it also makes sense to increase your y values by 1. Okay, so let's just call this 1. So this will be 2. This will be 3. So this is 4. And my 5 will be up there. Okay, so this point, let's just erase this point. Clean this up. This is where my function will start, right? 5, 0. And at 1, I am at the point 3, right? And at because again, this is not scaled perfectly at 2.5, my function has to be at 0. So again, you only need 2 dots if you're doing it this in a graphing paper, then all 3 of them will perfectly align. In my case, it doesn't because my graph is not scaled properly. Okay, so let's just connect this dot like this, and then let's see, and this is what the function will look like. Okay, so I'm not gonna ask you to graph. Okay, I think I'm gonna change this to just sketch. Okay, so just sketch it, okay, which means you don't have to label your x and y axis. What do I mean by that? So let's do this second question. Let's add a new page. Let's do the second question down below over here. So let me remove this. Okay, so now let's work with this function. You have 2y minus 4x is equals to 10. Again, in order to do anything, you have to have this form. Y is equals to mx plus b. So that means I need to get rid of this negative 4x by adding 4x on both sides. Okay, so this disappears. Now I have 2y is equals to, because this is addition, the order doesn't matter, right? So I'm just going to write the 4x first. So this just becomes 4x and then put the 10 after, okay? Because 4 is positive and 10 is positive, so this becomes 4x plus 10, okay? But I'm still not done because I have this coefficient. So I'm going to have to divide this by 2 and divide the whole thing by 2. And then this cancels out. So your function is y is equals to 2x plus 5. Okay, y is equals to 2x plus 5. And now, right, I'm asking you to sketch this. You're no longer graphing. So I'm gonna show you what I mean by that. Okay, so let's find the y-intercept first. Okay, so y-intercept is just given by, obviously this is your y-intercept, right? You can kind of see it by inspection, but if you do this by definition, then you have to replace x by 0. And when you do that, right, you're just going to get 2 times 0, which is 0, plus 5, which is 5, right? So this is your y-intercept, but your coordinate, if you want, right, your coordinate is when x is 0, y is equals to 5, okay? And it seems like I have a very similar function than what I initially had. Maybe I should come up with better examples, guys, because it looks very similar to the one that you have on top. X-intercept means that your y value has to be 0, so I'm going to replace this by 0. And then you get 2x plus 5, and all you have to do is just solve for x. So let's do minus 5, minus 5. This cancels out. So this becomes minus 5 is equals to 2x, and then you have to divide this by 2. Divide this by 2. Okay, this one is slightly different. Divide this by 2, so x is equals to minus 2.5. So this is your x-intercept, okay? This here is your y-intercept, but the coordinate that I'm interested in is when x is minus 2.5, y will actually be 0. And you can verify this, right, by plugging it in. So let me just make this a little nicer. And this was my y-intercept. So if you plug in negative 2.5 in this function, right, negative 2.5 times 2 is minus 5. Minus 5 plus 5 will give you 0. Okay, so that means you've done this correctly. Now, what do I mean by sketching? Let me add another page. So because I'm writing really big. So now I'm going to use these values to sketch my graph. So again, so let's, yeah, you know what, let's just do it this way because now I can see a lot of stuff and have a lot of room underneath as well. So remember my equation is y is equals to 2x plus 5, if I'm not mistaken. Right, 2x plus 5, right? So this is how you would sketch this. Okay, so draw your, this is not graphing. Okay, so I know one of the points. So at 0, right? So this is my point 5, right? So this is the coordinate, right? 0, comma 5. So at 0, my y value is at 5, and this comes from here. When x is 0, right? This is your x. This is your y. So when my x value is 0, y is at 5. And when my, and the other point is this one. So let's say this is the point minus 2.5, right? So this is my point minus 2.5 comma 0, right? Maybe I should um, do this a little differently. Okay, so So let me just yeah, put a dot over here, and this, let me just point this out over here. So this is the point when x is minus 2.5, y is equals to 0. Where is this coming from? From here. Okay, this is your x, and this is your y. That doesn't really look like an x, so let me just rewrite this. So this is x, that is y. And now all you have to do is just connect the two dots, okay? So connect the two dots, maybe let me do that in purple. So just connect the two dots, and this is the sketch of your function, okay? I don't really need you to label this or scale this, but if you, right, because it's just a sketch, okay? So no need to make this more complicated. Okay, kind of like what I did in my first example. You could, right, by using the table of values and increasing your x's, by looking at the denominator of your slope, you could graph this um, and scale everything. But let's not do that, because a sketch sometimes is tells you a lot of things, okay? A lot of things that we will cover next week that are important, okay? So these 2 points are, in my opinion, the two most important points in this graph, okay? So again, your slope is positive, right? So your function is obviously rising, but now you have this x-intercept, right? So um, this makes your sketch somewhat more precise than last week. Last week I showed you when I so for example, if you were to sketch this function last week, you did it this way: 2x plus 5. Not graphing, sketching, right? So your slope is 2. That means your function will increase, and your b value is 5. So you would have just sketched it this way: x, this is x, this is y. So start at the point 5, right? And because your function, the slope is positive, your function is increasing, this is what your function looks like. But now you have this additional point, okay, which is your x-intercept, okay? So this is the point 0, comma 5, and this is your point minus 2.5, comma 0, okay? So sketching, again, not too complicated. We're not graphing. So for homework, okay, the homework is not going to be that long. Again, this week, I'm not going to make it very difficult for you because you have a test coming up. Um, Homework, I came up with these questions. So in this case, don't graph, okay? Just sketch it, okay? So just sketch. Um, so that means you're gonna have to identify what your y-intercept is, what your x-intercept is, and then just connect the two, okay? And you don't have to scale your x and y axes, okay? So just no need to scale because you're not graphing, you're only sketching, okay? So make sure you're keeping this simple. But if you want to practice, if you would like to graph it, then you're more than welcome to do that. So I'm gonna post the solutions to this. I'm gonna post my filled in notes separately so that you can compare your answers to mine. Um, but I'm not going to do this in this video because I don't want to make this too long, and I want you to do this yourself, okay? So do this yourself and then compare your answers to my notes, okay? That is it for this class. Next class, we'll talk about domain and range. And again, those questions will not be assigned from the textbook, okay? I'm going to give you my own questions and my own solutions, okay? But anyway, for today's class, this is it. If you have any questions, send me an email or join me during my office hours on, I think I'm going to be holding my office hours on Wednesday, okay, because Thursday is your test, Friday is a PD day, right? So um, anyway, I'll share the link to that later on, okay? So that is it for today. Thank you so much, guys. Have a nice day.